Let's do a very simple example that you just cannot do using our formulas. Let's say I want a 30-year, $300,000 mortgage, and I want monthly payments of $1,500. Let's find I-12. Okay. So, right. So clearly to find I-12, we would first want to get the monthly interest rate, and then just multiply by 12 because I-12 over 12 is the monthly interest rate. To get the monthly interest rate, we could use our formula for an annuity, present value of an annuity immediate, and it would be, so basically you would be solving a polynomial of degree 360, and you really can't do that. You really it's just impossible to do that without a calculator or something else. So to do this problem, you're just going to need help from our calculator. So let me pop up my calculator. It's a bit annoying that you can't use the digital or the BA2 Plus emulator without plugging in the dongle into the USB plug. But anyway, okay. So let me move this over here and maybe move this over here. That's a lot better. Okay. Right. So before I begin, remember from previous videos that this is formatted in a very strange way. If I want to do something silly like e to the 7th, well, it only gives me up to 2 decimals. That's no good. And if I wanted to do something like 1 plus 2 times 3, logically you would get 7, but it gives me 9 because it does addition first, which I guess finance people sometimes like that. I find very strange. But anyway, so very quickly, let's go over how to format it. So you just go to format, which is second format down here. You hit 9, enter, and then quit, second quit. Now let's try e to the 7 again, 7e. Now this gives me up to so it's basically gives me as many decimals as we need. Okay, so it's going to spit out way more decimals than it did before. I think this only displays 6 decimals, but when you do calculations with you know, like if I multiply this by something else, the calculator will actually use 9 decimals to do calculations. Okay. And second, let's fix the 1 plus 2 plus 3 thing. So get out of this. Let's go format. Go up 1, set, second, set. So second goes to the keys up, that are printed above. Okay, so now this is set to the normal way of doing things. Let's check that. 1 plus 2 times 3. Sorry about that. I don't know what happened there. 1 plus 2 times 3 is 7. So all is well. Okay, so let's get to more interesting things, particularly how to do annuities in the calculator. So first of all, before I do anything, you need to understand that we have 2 basic types of annuities, annuity immediates and annuity dues, and annuity immediate is the default mode. Okay, and to switch to annuity immediate, sorry, to switch to annuity due, let's just do exactly what I have here. I always like to just go second quit just to get out of anything that I might be in. So you go to begin, which is right here. So second begin. You go to set, second right here. Okay. And you see a little BGN here. BGN means, I just said, begin. It means that annuities are now at the beginning of each period. Okay. All right, so let's go back to this problem here and see how we do basically get the answer. So we're dealing with a loan here, so I don't want an immediate due. I do want an immediate, an annuity immediate. I don't want an annuity due. So we do the same thing to just switch back, go to begin, set. And you'll see a second if there is a second. Whether or not, if you're wondering if you actually hit the button with enough force or if you hit it twice, whatever, there's a second there, so go to quit. And you'll see BGN is gone, and now we're into the default mode. Okay, so what do we do here? Okay, so we have to be a little careful here. So first of all, we're going to use these keys here. These are called the time value of money keys. Okay, so it's a 30-year, $300,000 mortgage. Payments are at the end of every month of $1,500. So it doesn't matter what order we enter information. So 30 times 12 is 360. So that hit 360N. N is the number of periods in my annuity. IY is the effective interest rate as a decimal. Sorry, as a percentage. We don't know what it is. We're going to find that out in a second. PV is present value. We don't know what the present value is, but that's okay. Payments are 1,500. So we'd enter 1,500 payment. Future value is the same thing as accumulated value. We don't know what that is. Actually, my apologies. We do know what the present value is. It's hidden here. Present value is how much you're being loaned. It's the value of the loan when you get the loan. So present value is 300,000, and I have to enter it as negative. I'll explain that in a little bit. So what we're going to do is compute IY, and we get 0.03655929795. Multiply by 12 to get 4.38711. And that is, right, so that is going to be the, as a percentage, the nominal interest rate compounded monthly for this mortgage. And I recommend you actually track that. You basically do the problem again by a formula, so track that you get this answer. Okay. Right. Okay, and let's do the same problem, but monthly payments are at the beginning of each month. Okay, so we're going to go to begin, set, quit. Okay, so same problem. All right, so let's enter everything here. And we should get very close to the same answer. It's not going to make all that much of a difference. So actually, So I like to always clear TVM by second FV, which is exactly clear TVM. So that clears all of these. It clears all of these. You can very easily see what these are. I'll explain that in a second. So 360 and 300,000. One too many zeros. Present value 1,500. And again, I'll explain the negative in a second. There's actually a very good explanation for that. So we go to compute IY, and then times 12, because this is as a percentage the effective monthly interest rate, multiplied by 12 to get the nominal monthly interest rate. And it's a little different, 4.41 or 4.42%. And I should mention when you input interest rates, you always want to input as a percentage. Okay? That's fairly important. But you are always entering an effective per period interest rate as a percentage. That's very important to remember. Okay. Right. So let's continue on. Yeah, so as I mentioned, to clear the time value of money keys, just clear TVM. And I just like to do that whenever I start a new problem. It's a very good habit to get into. You know, otherwise you might have junk answers, and unless needed, I like to keep my calculator on annuity immediate mode. Right, so let's talk about the memory keys, and this is extremely important. So you have 9 spots in the calculator to store things. So let's say I have some number, I don't know, ln of 5, and I want to store it. So I want to store it in the 1 spot. So I hit store 1. Okay. And then to get out of it, to do something else, I go to quit. Let's say, I don't know, I want ln of 9 in the 2nd spot. I go store 2, and then to get out of it, I just go to quit. Etc., etc. You can do this from 1 to 9. Actually, you can do this from 0 to 9. So you have, sorry, 10 spots. Okay, so let's do it in the 6th spot. I don't know, ln of 2. Well, let's do e to the 2. Just doesn't matter what it is. So let's go store, let's do it in the 6th spot. So by default, 0 is stored. Anyway, let's see what's stored where. So all you do is go to memory, second mem. So in the 0 spot, we didn't input anything, so it's 0. Sorry, you go down. So in the 1 spot is 1, 2 spot is, or sorry, 1 spot is 1.609. It was ln of 5. I forget what we put even for this, ln of 6 maybe. Then we didn't do anything until we hit 6. In which case it was e to the something. So yeah, you just hit recall 1, recall 2, as I mentioned. So, sorry, I didn't mention that. So you can go recall, it's kind of annoying, it doesn't change, it's M6, so let's get quit. So yeah, you can hit recall 1 to see what's in the 1 spot, recall 2 to see what's in the 2 spot, or you didn't put anything into the 5 spot or the 0 spot. So we did enter something into the 7th spot, maybe it was a 6th spot. Yeah, so the 6th spot, sorry. The alternative to going to the memory key, which has everything here, you can just do the recall button.
So what's nice about the recall buttons, as I mentioned but didn't get into last time, is that you can use it to recall what's in the time value of money keys. So by default, everything is set to, well, let's just input some stuff here. I don't know, I'm just inputting basically junk. Well, let's put something that's, let's put 5 for interest. It doesn't really matter what I put. And let's leave these two, let's not touch these two. Let's get out of here. Okay, so let's say you're doing some calculations and you want to just check what's in time value of money keys. So recall N, we put 202 for N. Recall IY, we put 5 for IY. Recall PV, we put 855, 555. We didn't put anything for payment, and we didn't put anything in for future value. So those are by default 0. Now, we do clear TVM to set everything back to 0. Let's check that everything is 0. Recall N, recall IY, etc., etc. So you can erase the memory. We talked about checking memory. You can erase the memory by going to, get out of this here, by going to the memory button. So you see, as before, we didn't change anything. 5 is in the 2 spot, 5 is in the 2 spot, and 9 is in the 7 spot. So you just, when you're in the memory section here, you go to second clear work, and voila, everything is back to the default 0. Okay, so before I get into, and as I mentioned, this is how you check the time value of money keys. Before I get into nominal and effective annual interest and discount computations, I want to talk about a little bit more about annuities and the calculator. So let's first just do an example of how to get the accumulated value of an annuity using the calculator. So it's fairly straightforward. So let me do clear TVM. And this is an annuity due, so I have to go into begin mode. So I don't remember if I mentioned this, but this, when it says end, it's in end mode, which is annuity immediate mode. Payments are at the end of each period. So we go to second begin, which we just did. We go to second set, and then quit, second quit. And you see BGN on top. Hence, we're in begin mode, annuity due mode. Payments are at the beginning of each period. Okay, so this is now straightforward. Yeah, I'm a bit paranoid with stuff being in the time value of money keys, as I think you should be, because the last thing you want to do is have stuff in the time value of money keys that screws up your answer and just makes you a little nervous when you're taking exam FM. Time is of the essence, so you don't have all that much time to check your work. Okay, so we have a clear TVM, and you can always use the recall buttons again as before to check that it's clear. Okay, so 20N, 20 payment periods, 3% interest. You input that as a percentage. Payments are 1,000 per period. So 1,000 payment, 1,000 at the beginning of each period. So we want to accumulate value. We do compute future value is same thing as accumulated value. And we get an interesting answer. 27,676.49 if you plug into your formula is correct, but you get a minus. And the meaning of this is very simple. And this is how the calculator treats these loans. Or rather, the calculator treats this as basically a loan. So for me to get $1,000 at the beginning of each period, one way to do that is to shell out $27,676.49 at the end of the 20 payment periods. To get the $1,000 at the beginning of each period, I shell out this amount. This is exactly the, really the 27,676.49 is the, value, the time value of the 1,000 per period at the end of the payment periods, at the end of the 20 payment periods. But to get the 1,000, I have to shell out this amount of money. Okay, so by that logic, if I want to get the $1,000, or rather, if I want to get the $27,676 at the end of the 20 payment periods, I would have to shell out 1,000 per period. And let's check that that's correct. So 20N, 3IY, 1,000 negative payments. So I'm shelling out 1,000 at the beginning of each period to get positive 27,676.49. So, right, and this is important to remember, particularly when you do interest calculations. So remember, we inputted, didn't really have to, we inputted minus $300,000 for this problem we did before. And we inputted plus 1,500. Let's see what happens if we don't do that, and instead we input both as positive. First of all, let me get out of BGN mode because mortgage payments are at the end of each month. So this is annuity immediate. So 30 times 12, 360N. 300,000 present value, that's the loan value. 1,500 payment, compute IY, and we get an error because this doesn't really make sense from the perspective of finance. It doesn't make sense that I'm getting 300,000 at the beginning of the 360 months and I'm getting $1,500 at the end of each month. That just doesn't make sense. I'm not charming enough for someone to give me that money. So let's just sorry. To get out of this, you just hit the CE line C. Forget what that even means, but doesn't matter. All right, so let's enter this like we did last time and check that we get the correct answer. 360N, 300,000 minus present value. Now this is the lender perspective. The perspective of I'm the lender, lending a person 300,000, hence shelling out that money. And I'm getting 1,500 at the end of each month. And now we get the same answer we got before, an effective monthly interest rate of 0.366% roughly. Calculator always spits out effective per period interest rate. And you always should input the you always should input the effective per period interest rate into the time value of money key for IY. And times 12, and we get the nominal interest rate of 4.387%, which I think is actually, around what interest rates are going for now. Maybe it's actually a little lower. Not really looking for a house, so I haven't paid too close of attention to where interest rates are at right now. We'll get back to that when we talk about yield curves, okay, so let's now take the perspective of the home buyer. So 360N, now as a home buyer, I'm getting 300,000. So that's 300,000 positive, and I'm paying off the mortgage by 1,500. Now we go compute IY, and we get the same answer because it is the same answer. It's just two different perspectives. Okay, so right. So I want to do something interesting. So let's say I want the future value of these 1,500 payments at this monthly interest rate of 0.365%. Now you might think, well, if I just go compute future value, I'll get that. And no, you don't. You get something very close to 0. And the reason is, with everything inputted the way it is, basically the calculator is treating this setup as an equation of value, which is not incorrect of the calculator to do, because this is an equation of value. The equation of value is I get $300,000 at the beginning of everything, and I'm making these payments of $1,500 at the end of each month. So everything accruing 360 months of interest, add everything up, you get 0. That's what an equation of value is. It's the cash in equals the cash out, or cash in minus cash out time valued is 0. Cash in equals cash out time valued. So that's all the calculator is saying. It's that, like, hey, the future value of everything, the future value of this cash flow, we'll talk more about that later, but yeah, the future value of this whole setup is 0. Well, the calculator doesn't exactly spit out 0 because it does rounding. So when you round and add everything up, you don't get exactly 0, you just get negative 0.0000000048. Something pretty damn close to 0. So my opinion is, if you want to, let's say we have this interest rate. So let's recall, let's store this interest rate here. Yeah, let's store this interest rate here. So let's say I want the future value of 1,500 at the end of each month for 360 months at this interest rate. What I would do is clear TVM and just re-input everything in. There are some shortcuts to doing this, but you know, the calculator sometimes is a little weird, and you really have to be careful. So in my opinion, you don't save much time by taking shortcuts. Just re-input everything in. So 360N. Okay, so we call 1, that's my percentage interest rate. Let's say I don't know the present value and I just want 1,500 payments. Let's do compute future value. And right, you get basically over $1 million is the future value, the accumulated value of these 1,500 payments. That actually makes a lot of sense. So let's actually check this answer. Basically, as an equation of value, the future value better be the future value of the 300,000, because the equation of value is the future value of these, time value these 1,500 payments is equal to 300,000. So you can date that anywhere you want. Present value is saying the present value of these 1,500 payments is 300,000. Future value is saying, if 300,000 accrues 360 months of interest, then we should get this 1,011,000 $1,116,11. So let's store this in the to spot, and let's just check. Okay, so right, let's take our percentage that we saved divided by 100 to get an effective monthly interest rate plus 1. Raise this to the 360. Okay, so that is the 30-year growth factor at this interest rate times 300,000, and we get exactly the correct answer. Yeah, so the future value of these payments is the future value of this $300,000 is $1,011,611.60. Okay, so like I said, my personal opinion is just re-input things into your time value of money keys whenever you have to change something. It's just you run the risk of screwing up your problem on the exam FM, and at best that'll just screw up one problem. At worst, that'll throw you off and make you nervous. But even if you screw up one problem that you could have otherwise got correct, that could very well be the difference between a pass or a fail. So I'm going to always just re-input everything whenever I have to change even one little thing for an annuity problem. Okay, last but not least, let's talk about nominal and effective annual interest conversions. So this is pretty straightforward. You just use the icon V button, and it's not a very subtle terminology or not a very subtle acronym. It's interest conversion. So, right, let's see how to do that. Let's do this through an example. Let's convert 3% effective annual interest to nominal interest compounded weekly. So many annuity and loan problems in practical finance involve nominal interest that it really is convenient to have a 1, 2, 3, snap your fingers, convert nominal to effective annual interest and vice versa. Though it is still very important for the exam FM purposes to have a thorough understanding of the mechanics and really how nominal and effective annual interest works. Anyway, so we go to second icon, and what should be here is everything 0. So CY is the compounding periods per year. Yeah, not very subtle here, CY. That's by default 1. Hence, by default, just by default, it's 1 compounding period per year. Nominal interest and effective interest are both 0. So here, already here, interest is compounded weekly, 52 times a year. We're given, we don't know what nominal interest is. We're given, so sorry, I should say you enter whatever, and then hit the enter button, and then a little equation sign will show up here. Scroll down or up, doesn't matter. Get to what you need. We want 3% effective annual interest rate. 3, enter. So we go to nom for nominal, not nom, I'm hungry. You hit compute. And let's check that this is our answer. And as before, you input things as input interest rates as a percentage. So let's go to store 1 here. Okay, so right. So we know how to we know how to do this. Or we should know how to do this through our formula. It's you take 1.03 3 to the power 1 over 52 minus 1 times m, which is 52, and that's a decimal, convert to a percentage by times 100, and that's exactly the correct answer, 2.95672. We saved it from the calculation here. Right, so it's 2.9567205 So it's I think they might have been a tiny bit different from rounding, but yeah, we get the correct answer. Okay, and last but not least, you just use negative rates for discount. And if you think about it, we didn't dwell on this too much, but really, if you think about it, it makes sense. A negative interest rate is the same thing as a positive discount rate. So, right, let's convert 3% effective annual discount to nominal discount compounded weekly. So basically the same kind of thing here. So here we have 3% effective nominal discount. So we input that as -3. It's still 52. There's no need to input anything here or change anything. You just hit compute, and you're going to get -3.045 as the effective nominal discount rate. And check, you can check with your formula that this is correct. So I want to say one last thing, and that is, you saw using the formula for nominal, for nominal discount was a little awkward, particularly to put the y to the power and the input the parentheses, because you only have one single line here. You can't really see what you're inputting. And for that reason, what a lot of people do, particularly on Exam FM, is they use the TI-30XS, Texas Instruments, to do calculations that don't require any of the time value of money keys or the icon conversion, just to do straightforward formulas. And the reason is just very simply, if you want to do, let's do the same thing. I'll input it and show it up on the video here. I'll make it a little bigger. Right, so give me 1 second. So, yeah, and we'll see just how much easier it is, really. Okay, so, right, let me make this bigger. And I'm hoping that this, well, it might be a little difficult to see, but anyway. So yeah, it really is much more easier on this calculator to see what you're doing and to do things correctly. And also in particular, this has multiple lines. It's a multi-view, so you can go up and down and check basically what you've done. So this calculator literally has the same functionality as your fancy TI 80s or 90s, except there's no graphing feature and there's no programming feature, which might be good or bad, but it doesn't matter because it doesn't have those features. It is Exam FM and Exam P allowed. You cannot use a TI, you can't use your graphing or your, anything programmable or graphing is not allowed in the exam. So what people do is they'll just bring both of these calculators to exam FM. I use this calculator actually for exam P. I really liked it. There's nothing really to dislike about it. It's the same as a expensive TI 8090, but no graphing, no programming features. It's like 20, 30 bucks. So, I mean, I probably would recommend that. Taking exam FM with both of these calculators, doing computations with this one's much easier, and using this to do, financial annuity and other calculations that we'll do, like net present value, conversion of, nominal interest to effective interest, and et cetera, et cetera. Right. And I don't remember if there's other calculators that are approved for actuarial exams in the United States. I mean, these two calculators are cheap and they serve the purpose very well. So to me, it's these two calculators are a good solution to the question, what calculator should you use for the actuarial exams? But anyway, okay, so in the next videos, we'll finish up annuities, and then basically videos on loans, and everything else is up already. So yeah, and this might be a little long, but I think it's good to get basically everything done in one video. The rest of the calculator stuff. All right, so long, take care, until next time.